This is the first of a series of videos to show some of the new functionality in JustMacros. We've got a BCF 2000 here, kindly lent to us by ATEM user Esnick. You can pick these up for a few $100s or just under £200 in the UK. So using JustMacros MIDI functions, we can map these faders, the buttons, the pots to any of the settings of the ATM, the settings of Casper CG. We can trigger entire scripts from buttons. Anything you can do in JustMacros we can now assign from a relatively cheap surface like this. So if we look at some of the simple functionality, we've got the first 5 buttons on the bottom row are preview source buttons, so you can see as we change it the light is indicating which source is on preview, and you can see on the multi-view it's changing. The buttons above are doing the same thing for the program sources, so we can end up with a nice selection. We've got a cut button there, and we've got an auto button just to show some of the actions. I also have a button to turn the downstream keyer on. It's a full frame graphic coming from our renderer, so it's filling the whole screen, but you can see if we open up the Black Magic software, that's turning the ATM on. Off again. My button in the bottom corner is allowing me to run the fade to black and auto transition back from fade from black. This button we've got assigned to turn the key 1 onto the next into the next transition, and obviously it toggles in and out, and this one turns it on the TX. If we move to some of the pots, the pots we've got assigned the first one to left right, up down, stretch it out XY, and stretch it out vertically. We can even use the ATM's fly rotation, spin her around. This one will allow us to control the border size and the sharpness of that border, softness. So you can see it's really very simple. I've just very quickly picked a bunch of settings. You obviously would use the ones that most suit your needs. If we turn that off, this particular panel is clearly geared towards audio, so if we have a look at the Black Magic audio, you'll see that when we move the faders, they move very quickly in the Black Magic software. There's no latency there, and it's it's nice smooth movement. There's no problem doing 2 at once or 3 at once. It's very easy, and because this particular panel has motorized fader control, it means that we can actually pick up the faders and move them in the software, quickly or slowly. This is really useful when maybe you've got one user using the panel to control and another user using the software. Everything can be kept nicely in sync. One of the great things about these panels is they have a bit of logic in them, and you can reassign. You're not just limited to these 8 controls and those 8 controls. So if we just quickly change to our preset number 3, you'll see all the faders have changed. That's because this preset is actually used to allow us to control the light level in here. So if I push the lights right up or bring them right the way back down again, all the way to nothing. The lights I'm using are some disco lights, so we can actually control the color of the lights as well. And so if I just drop away, we end up with a very red light. Bring the red light down, push the green light up, push the blue light up, and bring the green down. And you see, can really have any control that we like of the lights. Because it's JustMacros and we've taken snapshots of some of these things, then we can pop open and have a look at some of these ones we've done before. So if we go back to the red, then bang, the faders are controlled and it all happens very quickly. Go back to the blue, some nice soft warm light, and back to our normal light. By the time we got to the end of this series of videos, I will have introduced the idea of graphical user interfaces for JustMacros. Ultimately, all of the mapping required for the MIDI panels, X keys and anything else will be done through the use of JustMacros GUIs. However, these GUIs will be completely user configurable, and therefore it's important to understand what's going on behind the scenes, so to speak. So I just want to spend a little bit of time running through the scripts that are involved in just mapping a MIDI fader to an ATEM audio panel in both directions, because we're using both MIDI in and MIDI out to do this. So if we start at the beginning and have a look at the generic MIDI samples, you'll see I've written in generic MIDI events raw, I've written some standard handlers for dealing with the low level on MIDI device in message, which you might have used if you've been using one of the earlier patches. So what this function does, and most people won't need to edit it, is it just breaks down the status bytes and the data bytes into kind of more manageable MIDI messages and passes them on to generic MIDI events user. And what you'll find in this script is a function or an event that will fire for note on, note off, polyphonic pressure change, control change, reset all controllers, set local mode. All of the individual standard MIDI functions are broken down, and instead of receiving status bytes and data bytes, you get meaningful parameter names. So if we look at how that works, if I just turn on the raw logging of MIDI data and then we have a look, you'll see that when I move that fader, let's just scroll that up, you'll see that we're getting status bytes and the value, and you can kind of figure out what's going on, but it's not very easy and meaningful. And the same is true if I use buttons. Sure, you can see the status byte has changed, but that's not very helpful. However, if we also turn on the logging in the control change user events and the note event, and save that script, let's clear the screen. We have a look at note first. So we'll do a couple of notes, and then we'll have a couple of those. So if we have a look at this, what you'll see is that we get a raw message followed by the user message. So the status byte and 2 data bytes on these first messages get converted into a MIDI note on user event handler and the values that have been passed to that user event. If we have a look at one of the ones further down, we'll see the status byte 176 1545 gets converted into a MIDI control change, device 3, channel 0, control index 15 and a value. So you see that by using my kind of standardized functions, it just makes it a little bit easier to attach your actions to the MIDI messages that are coming in. So if we have a look at these notes, you can see that what happens is it checks that it's coming from the right device, it checks that the velocity is greater than 0, and then for each note I've just got an if command that is saying if the note is this, then set the preview input equal to that value, and if the note is something else, then set it to another value, and that's all there is to it. If we have a look at the control change, then again I'm looking at the controller number and I'm setting the audio input gain to a value. In this case the value has to be calculated because the MIDI messages are always going to deliver us a value between 0 and 127. What we do is we divide that value by 127, we multiply it by 66 and subtract 60, which gives us a rough approximation to the Black Magic ATEM fader level between -60 and +5. There are some other values being calculated in here to help us with the key positions, but really you can see that just for each mapping I want to create, I've basically got one line of code. Right, Because the faders on this panel are motorized, we also need to be able to send MIDI messages to the device. And we do that by using a slightly different technique. And you can find that in the samples folder under MIDI scripts. And if we look at BFC profile 4 to 8 ATEM audio faders, you can see that it uses a couple of scripts. So this is the main script, and at the top of this script we've got the setup of an array, and basically this is just creating an array for us to hold what channel number, MIDI channel number and controller number, and what its current value has been set to. So then we've just got a very simple loop which goes on forever. So what we do is we write an environment variable saying we want to monitor the ATEM audio levels, and then we go around a loop while that environment variable is set to true. The next thing, or the part of the code that's doing all the work is here, and it's simply looping around from fader 1 to the number of faders we've got, and we're reading the audio input gain from the ATEM. We then do the maths on it again to convert it from minus 60 or minus infinity to positive 5 to a value between 0 and 127, and then we check that value is the same as is in our array. If it isn't the same as in our array, that indicates it's been changed somewhere, and therefore we simply send a MIDI message control change to our BCF 2000 device, setting the channel number, the control number and the value we want to set it to. So effectively it's just doing the exact opposite of what happens in the event. And to stop the processing, we just go to a stop, and we're simply going to write the environment variable that says we no longer want to be monitoring the ATEM, and that will allow the first script to come out of its never-ending loop and log the end command. And that's it. That's how it works. The same thing is done for the lights. If we have a look at the DMX and we have a look at the start, you'll see it's very, very similar. We have an array at the top which holds the current values, or the last value we sent to the faders, and then we go round a never-ending loop, and within that never-ending loop we go round a loop from 1 to 8 on the faders, and we check its DMX value, again adjusted. So the DMX value is between 0 and 255, so we're just dividing it by 2 to give us our 0 to 127, and subtracting 1. And again, if it doesn't equal the current level, the calculated level, or the array doesn't equal the calculated level, then we send the MIDI control change event again. And it's really that simple. If you click on Task Manager, you can see all of your update processes running away in the background, and as long as you keep a sleep in your script, then you'll find that it won't use any of your processor. Okay, I hope this helps. You write your own MIDI scripts, and if you've got any questions, obviously post on the ATEM user forum. Thank you.